Right, today I'm going to be talking about vectors. We're going to do an introduction because we haven't done them before. So vectors are just describing movement. So we're really talking about how we get from one place to another on a Cartesian plane. So we should be looking at a grid. So really what we're doing is we're having two coordinates, one up the top and one down the bottom, and they're describing, so the top one is describing sideways movement and the bottom one is describing vertical movement. So we've got horizontal and vertical movement. So these numbers are going to tell us which direction we go. So if the number is positive up the top, we're going to the right. And if it's negative, we're going to the left. If the number is positive on the bottom, we're going up. And if the number is negative on the bottom, we're going down. So that's just telling us where to go from a certain point. So you always have to have from somewhere to somewhere else. It's directional. So let's say that I have a graph. And we'll put in a few points and we'll talk about how we get from one point to the other. Okay, so let's say that we've got one point here and we've got another point here. Okay, so we're going to go from here to here, and vectors have arrows on them, right? They're talking about direction. So this is A and B. And the way that we write it is AB with a line and an arrow. So we're talking about the direction we're going from A to B. So if we want to describe this using a translation matrix, what we're going to do is say, or a column vector really, let's just call them column vectors because that's what the book is going to call them, column vector. All right, so we're wanting to know how we got from A to B, and the top one needs to be sideways. So we're going 1, right? We only went from here to here. So we went right, so it needs to be positive. Then how did we get from A to B on a vertical sense? We went 1, 2, 3, 4, 5, but we went down, so it has to be -5. So that is the column vector for how to get from A to B. Right, let's do another one, shall we? I'll just change colors. All right, so if I have this, let's put in some markings again. All right, so let's go from here. And we'll go over here. All right, so I'm going to call this one A and this one B, and we'll have the arrow going this way. So again, I'm going to say the column vector for A to B is, so let's look at the horizontal thing. We went 1, 2, 3, and we went to the right. So it's still 3. It's a positive number. How many did we go up? 1, 2, 3. So it's also 3, and it's positive this time because we went on a vertical scale. All right, so it's pretty simple just to mark down what we're doing horizontally and what we're doing vertically. How do you get from one thing to another? All right, the second part is about adding. I'm just going to save this. It's about adding and subtracting vectors, and it's really, really easy. You'll be happy to know. So let's say that I have a vector that is 3, -1, and I want to add to it -3 and 7. All I do is literally add the numbers together. So 3 plus -3 is 0. -1 plus 7 is 6. It's just that simple. Let's do another one just for funsies. All right, again, add the top two numbers together. -2 plus 4 is 2. 3 plus 2 is 5. Ta-da, we're done. You can also subtract them. So what if I want to subtract? If I have 4 and -2, and I want to subtract 1 and -5, I'm going to subtract. 4 minus 1 is 3. -2 minus -5. So remember, if you're subtracting a negative, these two things become a positive. So this is -2 plus 5, which gives us 3. All right, same thing. Let's say that we've got -1 and 6, and we're subtracting 2 and -1. All right, so -1 minus 2 is -3. 6 minus -1, well, these two things become a plus, so that becomes 7. So that is what 32.2 is about. So 32.2 is about adding and subtracting vectors, and 32.1 is just about describing the vectors. Or you might be given a vector. So you might say that AB is 1, -3, and ask to draw it. But what they'll do is they'll give you an actual place as well. Let me just see. Okay, they won't give you a place. All right, so what you're being asked to do then is just put it on a grid. Oh man, I should use actual. Let's do that. Okay, and then we'll have some lines. Okay, so directional vectors or column vectors, they don't actually matter. It doesn't matter where they are. So you're not actually talking about where on the grid you are. You're just talking about where you move around. So you don't actually need, we're just going to pretend these lines are straight. You don't actually need to have any sense of reference about where you start. I am going to pick literally anywhere to start. That's going to be A. I could have picked over here. I could have picked over here. It doesn't matter. So A to B, I need to go across and down, right? So I'm going to go across 1 and down 3. 1, 2, 3. And that is my vector. I could have done it in a different way. Let's pick a different color. I could have started here and gone across 1 and down 3. 1, 2, 3. This is also AB. I could have done it over on the other side. You get my point, right? I could have done it here. 1, 2, 3. There we go. This is A and this is B. All of these are correct answers. If you're given a starting point, then use that. But a lot of the time, they don't give you a starting point. They just ask you to draw it anywhere because it's about the difference between them, not about where they are. Okay, so that is 32.1 and 32.2. Go ahead and do your work. Good luck.